Alright, so it's time to go ahead and verify a few identities. These ones are just a little bit tougher than the ones from our last lesson. I need to show in the first example that the stuff on the left is equal to the stuff on the right. So I'm going to start with the complicated side. I'm going to start working with that and see if I can get that to equal sine squared. Right? Okay, so let's start off. I see a secant squared, which makes me automatically think of my trig identities. And here's what I know. I know, based on prior knowledge, that secant squared is the same thing as tangent squared plus 1. So I'm going to go ahead and I'm going to substitute anywhere I see a secant squared, and maybe these. I'm going to substitute in tangent squared plus 1. I'm going to see where that gets me. I don't know if this is helpful. You know what? I don't need to go that far. I just noticed something. See, I only have one denominator. Really, that's two fractions over here. So forget that step. Over here, I can rewrite this as my first term will have a secant squared on top of the fraction. The second term will have a negative 1 on top of the fraction. And both of those are written over secant squared. I can break this up. Boy, this is a much easier problem than I thought. The reason this is nice is because I have secant squared over secant squared. Well, those go away. That becomes the term 1. 1 over secant is the same thing as cosine. So 1 over secant squared would be the same thing as cosine squared. Now I'm trying to prove in all of this stuff that it's equal to sine squared theta. So I'm going to continue to write this off to the side. I want to show that this left side is equal to sine squared theta. The left side is equal to sine squared theta. And then my last step, and this is where I need to use the Pythagorean identities. I know that sine squared theta plus cosine squared theta is equal to 1. So if I subtract sine squared theta from both sides, it turns out that cosine squared theta is the same thing as 1 minus sine squared theta. That doesn't help me out. How about this? Boy, I'm really flubbing this right now, aren't I? I want to subtract cosine squared theta from both sides. And the reason I do that is because that gives me sine squared theta is equal to 1 minus cosine squared of theta. There we go. That's what I'm looking for. Because if you notice, I have 1 minus cosine squared theta there. And if you notice this, I have 1 minus cosine squared theta. So I'm going to take then, if these two are the same, I'm going to take this and plug it in for that. So in other words, I'm going to plug in sine squared theta for the left, and that is equal to sine squared theta on the right. That all checks out. Those two are the exact same expression. So when you do a verification, here's the idea. You're going to start with this, and you're going to end with a line that always looks like this. It's going to say sine squared is equal to sine squared, or something along those lines. The left and right side of the equal sign are going to be exactly the same. Exactly the same. That means then that your points, if you're doing this in a math class, or if you're doing this for homework or on a test for me or something like that, the points aren't for saying that sine squared is equal to sine squared, because everybody, all of you, should have the exact same expression at the end. The points are going to be coming from showing all of this work that's in between. So it's very important that you actually write out each step of your algebra, of your rearranging as you go through. Let's try the second example here. It looks a lot more complicated, doesn't it? So let's go ahead here and let's try to simplify it. So the first thing that I notice whenever I look at this problem is I see on the top, I see sine squared plus cosine squared. And that rings a bell. That sounds familiar, doesn't it? Because that's actually just 1. So I'm going to go ahead and rewrite this as 1 over cosine squared theta secant squared theta. That's equal to 1. And then I'm going to look at the bottom. Now, knowing that I want to take this and I want to turn that into 1, well, I think the only way that I can do that is if the denominator is 1, right? So that's what I'm thinking here. That's the only way that I get 1 out of a fraction is I have this 1 over 1 is equal to 1, right? Okay, how are cosecant and secant related? And then I pull into prior knowledge. I go, wait a second here. Cosine, if I take the reciprocal of cosine, 1 over cosine is equal to secant. Those are reciprocals, aren't they? So really then, I have 1 over, and on the bottom of the fraction I have cosine squared of theta, and I have 1 over cosine squared of theta, and that's equal to 1. Yeah? Well, that's convenient, because if I just look at the denominator now, I see that those two cancel out, don't they? So I'm going to put across both of these, flash them out, and I'm left with 1 on the bottom of the fraction. 1 over 1 is equal to 1. 1 equals 1. There we go. We just verified two identities. So there's a couple of examples to get you started. I'll create another video for the next ones in our notes.